Ma'am, able to hear me? Hello, ma'am, you're able to hear me?
Yes, ma'am.
Yeah, good evening, all. Nice to meet you again on the final day of the FDP on big data adaptations, right? And we have been, you have been traveling through. FDP on big data. You have been traveling through all the 4 days, okay? And I hope.
Recording in progress.
What are the new things that you have learned all these 4 days? Answers quickly on chat, please. What are the new things that you have learned on all these 4 days? Something for some, something would have been new. Yes, no? You're all there connected? You're able to hear my audio? Able to hear me? I don't know.
Yes, ma'am.
Okay. Once I don't get response, I thought there's some problem there. Okay. So good evening. What are the new things that you have learned? Yes, what is big data? Thank you. Those who have not answered for the past 4 days, I wish everybody to answer this. 1 or 2 words, what you learned something new on this 4 days before we jump into Apache Spark and Tableau today. All right, map reduce, HDFS. I'm getting a lot of answers from Lohit. What about others? Yes, please. Cassandra, yesterday we were seeing about Cassandra, MongoDB, you remember about NoSQL, yes, master nodes, Pig and Hive. Pig is for scripting, Hive is for query language. What is the language of Cassandra? Anybody remembers? The language of Yarn, yes, yet another resource negotiator. All right. I'm waiting for your answers. I'm not going to recap, you're going to recap. I don't know, something happened to my system. All right. Jesus. Oh. Yarn, yes. What about others? Pig, Hive, Yarn. So many of you are here. I'm not getting response from everyone. Okay, so the day one, we start with the big data analytics. What is big data analytics? And the solution of big data analytics is Hadoop. Then we went into Hadoop. Then we saw the two major components of Hadoop, that is HDFS and MapReduce. It works in master slave, the master components and the slave components we have seen. And the next day we saw about HDFS commands. What are the different commands available? How to push your data from your local system to Hadoop, and how do you merge the big data analytics on all such things, right? And then eventually we moved out into MapReduce. Remember, we were working with an inbuilt function of MapReduce and Pi function. Remember, Pi 3.14 is, and then we moved on into how do you write your own algorithm of MapReduce for word count we have seen, and also for Uber analysis. Thank you, Rohit. And this is what we have seen on day 2. On day 3, we saw about Pig and Hive. Pig the scripting and Hive the HQL language, and where and when you should use it. All right. And yesterday was day 4. We were seeing about KSN, the NoSQL, not only SQL, the Apache Spark and MongoDB. Some examples of snippets we saw. All right. Today we are going, hope my screen is visible to you all. Yes. Can I get a thumbs up if you're able to see this screen? It is showing us loading. Yeah, now, yeah, can you see? Yes. Yes, thank you. Yeah, 2 participants has raised their hands, so it's easy for us to see. It's all like closing our eyes and walking in a dark room, right? Conducting webinar, we don't know who is there, how they are there, and asking questions and getting interacting is the only solutions that we get. Thank you so much. And those who have not answered, this is the final day. Any question, try to answer at least once. Okay, we have 30 plus people. All right. So on this final day, we are going to see about the data visualization, how to visualize data using Tableau and Apache Spark. Is there anyone here who have already worked with the Tableau or Apache Spark? If you have already worked with Tableau, you can, yes, who has worked with Tableau or Apache Spark. If you have worked with Tableau, type Tableau. If you have worked with Apache Spark, type Apache Spark. Or if you have not worked with Tableau or Apache Spark, just type no. No. What about others? No. So it will be easy for me how to drive it out. Okay. So most of it, little bit about Tableau. Thank you. Okay. Okay. Thank you. So let's move on into this topic. Okay. So data visualization. So first we'll see about oh my God, it's I'm still in the older version. It's not 7/1/2021. It's 22. I don't know. My system is not responding to me to my sequence. That's what even I joined little late. I do one thing and this does the other one. Hmm. Systems are systems sometimes. Okay. Oh my God. Okay. So this is about Apache Spark. Okay. So yeah, most of you have said no. Okay, and it is taking so much of time today. Yes, my system gets boots up first early morning by 4 a.m. It starts its work, and that's what it is giving some problems. So Apache Spark, this is the logo of Apache Spark. Can you see like a star kind? This is the logo of Apache Spark. Now you remember you write programs in Java. Today I will show you. Today I will show you a demo of using Scala programming language and Spark, and also you can use Python. All right, you can use Python, and we work with Jupyter Notebook or Colab Safari. You can work on with that and PySpark. Okay, you remember we saw about Hive and external RDD that also can be taken into Spark SQL language and moved into data frames. Okay, so these are some technologies or languages that are associated with Spark. Okay, when it is with the Python package, it is PySpark. You can run it with Jupyter. You can work with a Scala programming language. Don't worry, some of the words are looking little new, but still you'll be able to understand something. So before starting with most active open sources community in big data, they're contributing it to the last year. Can you see Storm, Giraffe, okay, and then Hadoop MapReduce, and this is even more. Contribution of Spark is even more very fast in processing the high volume of data. Okay, what are the companies that uses Spark? Yahoo, Intel, Adobe, Amazon Web Services, eBay, IBM. Okay, some of it's Alibaba. Okay, Databricks, Red Hat. So these are the communities they work with. So I don't know how many of you know about Wikibon big data project in 2016. Okay, they made a research. Okay, when they made a research of enhancing systems of intelligence, they found this is pattern 1, data lakes pattern, and pattern 2, intelligent systems of engagement, and pattern 3, okay, this one is self-tuning of intelligence. And this, can you see a red dot and a peach color line? See how exponentially now we are in 2022 and how it is going to increase. So this is about Wikibon big data. Okay, projection by application patterns and percentage of Spark or streaming adaptation. Okay, how much $1 billion it is reaching? Can you see here? So annual big. So now adoption. Can you see here streaming adoption? And you can also see the word big data adoption is the name of this workshop. Okay, this workshop, or you call it as FTP, or you call it as FTP. All right, and now moving on to Apache Spark. Okay, it's a unified analytics engine for large scale processing. So the topic of this FTP itself is big data processing, right? Big data analytics. So it is used for large scales of data, including built-in models like SQL, streaming, machine language, and machine learning and graph processing and graph processing. Okay, so you can call Spark as an analytics engine, where it works even more faster than MapReduce, more faster than Pig, and more faster than Hive, and it can process huge volume of data with a lesser time. So what are the built-in modules that it uses? SQL, and also streaming of data, like video streaming and different streamings, right? Machine learning and graph processing, and also graph processing. Apache Spark is a lightning fast cluster computing. It is basically developed only for faster computation. It is developed only for faster computation, and it is built, and you see Apache Hadoop, Apache Hive, we have seen, right? Same thing here. It is built on top of Hadoop MapReduce. Okay, you're able to understand upon Hadoop MapReduce, and it extends the MapReduce model to effectively use for interactive queries. Can you tell me one or two applications that uses interactive queries and streaming processing? Any applications that you've used that uses interactive queries? How do you interactive queries? Have you worked on with that? Have you experienced? Yes, no? So when you it is I'm getting some. Yes, Python ID. Yes, Facebook. Exactly right. I was expecting that answer, right? I was expecting that answer. Okay, I was expecting that answer, because here so many times we go search our names, you search for some of your friends' name, even or older friends, okay, older friends whom we have not seen, just we get their names and we try to figure it out that they are there. Is WhatsApp. Okay, so when there is huge volume of data, and basically you are able to understand where Apache Spark is most used, where you have interactive queries and stream processing. Interactive queries and stream processing. So what you need to understand about Apache Spark is a lightning fast cluster computing. So today's data scientist, the first choice of language is Python. Okay, and both Hadoop and Spark provides Python API. Both Hadoop and Spark both provides, and I showed you in the MapReduce using Java. Maybe sometimes later we catch up. I can show you some demos, or if you want to learn more about it, you can contact our company. When I don't know when we start again our training on Hadoop or Spark. Suppose if it is your college and you want a training for set of faculties and students, you could approach. We could customize the syllabus according to your needs. Okay, so that kind of thing that we need to figure it out according to the schedule of mine. Okay, because why I always take the classes, because when it's you can set it for Hadoop, but it's not like very easy, like next you cannot install. You have some procedure, and if you got an error, you should be very efficient to debug it. Okay, and we have been successfully conducted workshop even with 50 students on Hadoop on 2 days or 5 days workshop, and they were able to do along with staff and research scholars. If you are really interested to equip yourself as an institution or as a group, you can approach to us. Okay, but don't leave only learning the theory part of it. Without learning the theory, you cannot jump into the practicals also. All right, so this 5 days is giving you a wide spectrum of technologies that are predominantly used in the current industry on big data analytics. All right, so that provides PySpark also. It provides, okay, PySpark, that provides a processing of big data and allowing easy access to big data platforms. So when did it all started? Apache Spark. Okay, in 2009, a team of Berkeley developed Spark under Apache software. Sorry, I don't know, something happened to my system. It's not listening to me. It is working on its own style. Okay, it sometimes it becomes like a children, right? They don't listen to us. So under the Apache software license, okay, and now it is Apache Spark is spreading like a wildfire. Okay, some top companies that uses are Alibaba, Yahoo, Apple, Google, Facebook, Netflix. You see all these people, they use interactive queries. Yes or no? How many of you agree to it? Type, at least write one letter yes on the chat. If it is not, type one letter N on the chat. Do these companies uses interactive queries? Yes. Only 2 answers out of 30. What about others? Yes. Yes. Right. So you're able to understand where really it works, where you have interactive queries. Sometimes we are not blind. Okay, we have a sight, but we don't have a vision. Same way also we travel. When you are computer inside, when you each of you are computer scientists or computer professors, right? We have a sight, but we don't have a vision. Okay, because you have got some vision, you have come into this FTP to learn yourself, to equip yourself. All right, so today's company, see Alibaba, a lot of interactive queries and super fast computing. Yahoo, maybe Yahoo is not as it is okay, and Apple and Google and Facebook and Netflix, they use and Spark, they all use Spark. According to the recent latest statistics, Apache Spark global market is predicted to grow with a CAGR of 33.9. Imagine the voluminous, okay, 33.9 between 2018 to 2025, and this is a greater spark for you to get yourself equipped onto this latest technology. All right. Okay, so Spark is open source, so you need not pay anything. It's a cluster computing framework, as I said, with an in-memory processing ability. What is the ability it has? In-memory processing ability. So it was developed using this language. I'll be showing you a demo of Scala programming language, whether it is while it is similar to MapReduce, okay, and it packs lots of features and capability that makes an efficient big data tool. What the only thing that made a Spark to spread like a wildfire is only of its speed of its work. Speed is the core attraction of Spark, okay, and also it allows when you want to work with Spark, you can speak with the Scala language, you can speak with you can compute with sorry, you can compute Spark using Java, Python, or languages. Okay, so in today's session, I'll be showing you the demonstration with Scala. Okay, with Scala. So what are the core components? What and all you can do? As I said, it is used for super fast computing and also for streaming, right? So where you have interactive queries. So MLib is for Spark machine learning libraries. SparkQL, you saw HQL, it stands for Hive Query Language. CQL, Cassandra Query Language. You remember yesterday we saw about CQL, and streaming and graphics. These are the major four components of Apache Spark. Okay. Now coming into, see, you can, do you remember this yellow elephant? Remember? Okay, it's Hadoop. Cassandra, you remember the I, yesterday we saw it's open source. You remember Hive? Yes. Postgres SQL. Okay, CSV, comma separated values. I told you about JSON, that's one format. Okay, JavaScript object function, you know about MySQL and Elasticsearch. So your data could be in any place. It could be a local data, it could be onto Hadoop data, whatever it is. If it is CSV, it's a local data. If it is the same CSV is on Hadoop, then it's a Hadoop data. Okay, it could be in Cassandra. Then it goes to the Spark core is the first component. The data frame API. Can you see Spark SQL, Spark streaming, MLib, and graphics? This is what we have seen on the previous slide also. Okay. It's not going to the previous slide. Okay, so these four components along with the packages. Okay, so from any data source you can take, and I told what are the languages that you can use. You can use Scala, you can use Java, you can use Python, and also R languages can be used. Okay, what is Spark, Apache Spark core? So we'll start with the Spark core. Okay, Spark core. All right, it's the underlying general execution engine for Spark platform. Okay, and it provides in-memory computing. So this is what you have to understand very clearly. It allows in-memory computing and referencing data centers that are in different external storage systems. Okay, when you take Spark SQL, it's a component on top of Spark core. You can see Spark SQL. It uses a new abstraction called a schema RDD. Okay, so it's provide here also you can work with both structured data and semi semi-structured data. And streaming, it's leveraging for fast scheduling to perform streaming analytics. Okay, it injects the data in mini batches and performs RDD. You have to understand when you speak about Spark, it's in-memory computation. The second word that you need to understand is RDD, and next is DAG. DAG, you always know about it. RDD, stands for resilient distributed data set. Resilient distributed data set. So that is how it works. And MLib, machine learning library, it's a distributed machine learning library above Spark. Okay, memory based Spark architecture, you have benchmarks or an ALS implementation. Okay, against, and it's 9 times faster than Hadoop disk based version of Apache Mahout. You remember I showed you about Hadoop framework when you were able to see about wherein you were able to see about, and Mahout is for machine learning. So if you are using Mahout more than that, I recommend you to use Apache Spark, because which is 9 times faster. And GraphX is a distributed graph processing framework that runs on top of Spark. It provides an API for expressing graph computation modeling of user-defined graphs using Pragal abstraction. So don't think there is a component of it. Once you dig and learn to it, you'll be learning more. So I said Spark is very, very fast, high performance for both batch and streaming data, and it uses the DAG scheduler, a query optimizer, and a physical execution engine. So I will show you the steps how Spark is getting executed. So how each step it moves. Okay, so it's easy to use. As I told, it also provides 80 high level operators. Okay, it can use in Java, Scala, Python, R, and SQL. Right, so it provides a collection of libraries including SQL, data frames, MLib for machine library, GraphX, and Spark streaming. And so it's very, very lightweight analytics engine which is used for large scale processing, and you can run on Hadoop, you can run on Apache Mesos, you can Kubernetes standalone or onto the cloud. Okay, so what are the uses of Spark? Okay, the data is generated by the system are consistent and combined for analysis. Okay, and use the process of ETL, extract, transform, and load. It used to reduce the cost and time required for ETL. Okay, and streaming process is always a difficult to handle in real-time generated data when you have a real data of streaming, right? But Spark is able to operate streams of data and without potentially fraudulent operators. Okay, and machine learning approaches becomes very, very feasible and increasingly accurate due to enhancement of voluminous operator. If you have got a data set which is so a huge volume, you can put the data. Okay, okay, and it makes the works easier. Okay, when you take interactive analytics, okay, it is able to generate response faster. It's able to generate your response faster for interactive analysis, right? For predefined queries. How many of you have worked with Google Analytics? I don't know. If you have time at the end, I will show you. I've said Google Analytics and also for digital marketing courses. Okay, we have done it for my company, CIRF.co.in, and that it uses Spark. Okay, it's 10 to 100 times faster than Hadoop. Okay, it's simple in data processing, it's more efficient and multiple tools, and it could be easily integrated to existing Hadoop structure also. So as I said about Hadoop master and slave, Spark also uses master slave architecture. Are you able to understand now what we have seen, or am I fast? At least the concepts you're able to understand before we move on to how the workflow works. So we saw it's faster in computing, it uses in memory, and RDD it uses, and what are the companies that it uses? Yes. Yes. Here, try to understand something about, yeah, thank you. Because most of you are new to it. As we go on, you'll be able to understand more. So now we are moving into the architecture of Spark. Okay. So Spark, it is going to use master-slave architecture, a single master and multiple slaves. Okay. So the Spark architecture depends upon two abstractions. Okay. I told you about RDD and DAG, which is directed acyclic graph. Okay, resilient distributed database. So RDD object, can you see here? You have an RDD object. From the RDD object, it goes into a DAG. And also you should remember Spark is using for both structured data and semi-structured data. Then it goes to DAG. It splits the graph into the stages of tasks that it should do and submit each stage as it is ready. Okay, then once the task set is made ready, it goes to the task scheduler where you have a cluster manager. So launches task via the cluster manager, and once the task is done, it goes to the worker node. Okay, from the task schedule it goes to the worker where you have a block manager and threads, and it executes the executes the task and stores and serves the blocks. Stores and serves the block. All right. So the first step, you have a RDD object, resilient distributed database. From that RDD, you are going to build DAG. Okay, DAG scheduler. So it splits the graph into what are the different stages. So first stage, you need to do that, second stage, and eventually and submit each as ready. Once the tasks are split, okay, and once it is ready, from the DAG scheduler, it goes to the task scheduler. So in the task scheduler, it is trying to figure it out, and then cluster manager, where it goes and assigns to the worker node. Okay, so these are the four steps: RDD, DAG scheduler, task scheduler, and worker. So if you've got a bigger task to do, for example, how do you do, right? If you have a bigger task, if you want to make a food recipe, first you prepare what are the vegetables you need, and then you prepare what is the vessel that you want to do, and you have a sequence of tasks, right? First, how do you do it? What you're going to pour oil, and then onions and tomatoes, the masalas, the mustard, whatever it is, you have a sequence to do it. Once the task is scheduled, then you start working with your work of it. So like that, how you have a bigger task, you schedule it, you task it, and you complete it. So you have got RDD and DAG are the most important, and Spark, and then the task scheduler. So coming into RDD, okay, are the groups of data items that can, I told, right? Spark uses in-memory locations on worker nodes. So restores the data on failure. If there is a failure, it restores the data. That is what it is called as resilient. Distributed data is distributed among different nodes. So you remember I told you there is a master node and a set of slave nodes, and data set is a group of data. Okay, data set, you say it is a group of data. Are you able to understand what is RDD? It's a resilient distributed database, and the nodes, even on failure, it is able to retrieve it, restores the data on, and it's distributed. See, the data set is not only on one node, it's distributed into different nodes. You remember about sharding also we saw, right? And then the data set is a group of data. So that's the first component. The second is the DAG is a finite directed graph that performs each sequence. From RDD, the data set is pushed into the DAG scheduler, where it makes from the graph, it makes the sequence of how it is to be computed. Okay, if you want to do an addition, you cannot do the addition. First, you need to get the data, then what computation, then you get your results, right? So the sequence of computation, if you want to do a word count, you need to map it up, and then you have to find the count, and then you need to sum up the same words onto the count, right? So each node in RDD partition and edge is a transformation on the top of data. So then what, as each node is onto different partition, you create you take data from different sets, and you, okay, refers to an aggregation directed and acyclic is done. So you have a driver program and you have a Spark content. Okay, once you get it from the RDD, then it goes to the DAG. After the DAG, it goes to the task scheduler when it sequences. Once it is sequences, it goes to the cluster manager. Okay, in the task scheduler, it goes to the cluster manager, and then it is going to the each worker node where it executes the tasks. So this is the last part of it. So entire task, the cluster manager, and before you have, first you have an RTD. From the RTD, it goes to tag, then it goes to the task scheduler, cluster manager, and the worker node. So you are able to understand this, the workflow of it from RDD. So from RDD, it goes to the task scheduler. The task scheduler is the cluster manager and then your worker node. Yes, this is how the Spark workflow works. Okay, from the RDD to DAG, where it sequences and goes to the task scheduler, where your cluster manager, and your worker node, where your tasks are getting executed. Okay, where your tasks are getting executed. Oh, it's getting time. Okay, so cluster manager is to allocate nodes and execute a unit of task that is to be done. All right, so I'll show. I think my entire screen is seen to you. Yes. Yes, no, no, yes. Okay. So you can go into this website, Apache Spark, and you can download the latest version. I'm going to start my Hadoop. We have less time. Start all.sh. Okay, I'm starting my Hadoop. Sorry. Okay. So once I start my Hadoop, I'm also going to start my Spark shell. I can take a data from local system. Otherwise, I can also take okay. I'm going to take a new window. Okay, I'm going to start my Spark shell. I've already, you can go, I don't know, sometimes it's very, the system is rebellious with me today. And starting, Hadoop is getting started. You can just search on Apache Spark. Okay, Apache Spark. So this is the website of Apache Spark. You can go on to downloads and you'll get the downloads part of it. So I have already installed Hadoop. If you want to learn about Hadoop installation, you can approach me at the end of this session, or when you want to learn, or if your students would like to learn. Okay, so this is the website of it. Okay, so here I'm going to start my Spark shell. Spark hyphen shell. Can you see? So once I install, then I get into my Spark shell. So once my Spark, the shell gets run, I don't know, it's very slow today. And this is also starting. Okay, still it is starting. So before it starts, I will show you. I think you're able to see my entire screen, right? Yes or no? You're able to see my entire screen? Yes, no? Okay, thank you, Lakshmi ma'am. So if well, there are different types of RDD. The first RDD that I'm going to do is a parallelized RDD. So I'm giving once the Spark is starting, I'll get this like Scala, because I'm going to show you a demo of Scala programming language. A Scala. So val data sc.parallelize of list 10 comma 20 comma 30. Okay, 10 20 comma 30. So once I give it, then it creates a parallelized RDD. I told you, na, resilient distributed database and the data set. And then if I give data.collect, I get the answers like this. So if I want to use map function, so I'm giving another variable, data.map. So I in my data variable, I'm going to have 10, 20, and 30. Data.map, I'm using .map function. X is equal to x plus 10. So this 10 will become 20, 20 will become 30, 30 will become 40. I can show you the demo once the Sparks gets started. The Spark is getting started. Okay, so the Hadoop has got started. If I type GPS, yeah. Can you see here? If I type JPS, I have got a name node, a data node, all right, and also can you see Spark submit? Can you see here? Because I've installed Spark. Okay, but still it is loading. Okay, before it gets loaded, I'll show you the codes. Okay, then I'll show you how it works. All right. I don't know. Today my system is totally uncooperative. Usually it's very fast. I don't know today what happened. Okay, so can you see on my screen? This is how I for only one method of RDD I'm creating using parallelized RDD. Okay, parallel collection of a list of 10, 20, and 30. And then if I give data.collect, so I'm creating val data. Okay, and then I'm parallelizing sc.parallelize of because it's scalar. And once the RDD parallelized RDD object has been created, then data.collect I get it. Okay, array 10 comma 20. So it is on the variable called data. I'm declaring another variable where map function this data dot map of x is equal to greater than, so x plus 10. Okay, so when I give map function dot collect, so this 10 is added with this 10 because data is on to 10, 20, and 30. So mapping whatever value I give 20, 30, and 40. Still Spark is getting loaded. Oh my god. Actually, it should be fast. I don't know. Okay, let's not waste time onto that. Okay. So the same thing I wanted to show you the example of word count also. I'm going to use a text file dot map line dot split. Okay. So then size reduced by, so and also import java dot lang. So first line with sparks dot cache, line with sparks dot values. All right. And how does it count a character and a word? Okay, character and a word. I can also take text files. Okay, so I'm just taking a text file from this. All right, val text file is equal to spark dot read of text file readme dot, you read every spark and every application it has readme. Then I'm going to find the file count, and the first thing only where I have a string of Apache Spark. Okay, lines with Spark alone is getting done. And so I don't know if Apache Spark, yeah. Can you see now? Yeah, well done, it has come. I'll show you the demo of it. Can you see Scala here? Yes, can you see the word called Scala here? Yes. Okay, so I'm going to give val data equal to ac dot parallelize. Okay, sorry, parallelize of list of 10 comma 20 comma 30. I'm creating a list of 10, 20, and 30. I told it uses RDD. You remember Resilient Distributed Database. And the latest version I've installed Spark version 3.2.0. Okay, so I'm just using, can you see here? Or it's very small, I don't know. You're able to see? Can you see? Yes. So the R dot Spark dot Apache dot Spark RDD, it's a parallel connection because I've used parallel RDD. Okay. Then if I give a data dot collect, Okay, collect is used once I store it onto how it views the data has been set. I can see, you can see it as res of 0 of array of 10 comma 20 comma and 30. That is on stage 0. Yeah. Can you see here? Array of 10 comma 20 comma 30. And then I can use val map any variable. I'm giving map function, which is already my data has got 10, 20, and 30. I can give array of which is equal to data dot map x. I'm declaring another variable which is equal to x plus 10. Okay, so it is computing the function of x. Each x value is taken, sorry, each value on the data. So can you see here map partition rdd, because I'm using the map function. If I give dot map is the function, I'm declaring this variable as dot map dot collect. Dot collect. So same way I can also read values, like how you read values. Also I will be able to read values. Okay, val text file. Okay, I'm declaring variable called the text file, which is equal to spark dot read dot text file of readme.md. All right. So it creates a text file. Before I told you we did an RTD. Here I'm taking a text file on the Spark folder. Okay, the readme.md. All right. So I'm declaring it on the variable called text file. Okay. Then I can, once this is done, I can using this variable text file dot count of. Okay. System has become very okay. Is getting loaded. Once it is done, I get a SQL data string. Yeah, I have to go to the path before I run onto it. Since I don't go into the path, I'm getting this. Okay. So this is what I ran and I kept. So text file dot count of, if I'm going to give, then you get what is the size of it. Okay, long and 119 text file dot first of function. So the first string that I'm going to get is Apache Spark on readme. Then I'm using lines with Spark, so I'm using text file dot filter function. Okay, where it is going to find only the word Spark is there onto the readme file. Okay, then lines with Sparks are being taken, so 19 places it is there. Then I'm going to line with Spark first of function, used to give the first line where we have Spark. Okay, and then using that text file lines with Spark.cache, the count and all those things, we'll be able to work on with that. Okay, so if you want to work with Python Spark, okay, we use PySpark. Okay, here you uses Python language. What I showed you is a Scala. What I showed you is Scala. So we have less time. So we now jump into Tableau. Okay, so one of you said you have seen something about Tableau, knew little about. So it's a graphical representation of information and data. Okay, you have got charts, graphs, maps. Okay, so which helps us to find, understand what is the trends. Okay, you know about COVID data analysis, right? analysis. All right. Then it understands the trends. When there is any outliers, it finds any outliers are there or any patterns in data. All right. So Tableau is a data visualization tool, or you can call it even as a business intelligence tool. You can also call it as a business intelligence tool, where you can show data in the form of chart or report or very fastly, and also doesn't require much of programming skills. If you're using any data like big data, Hadoop, SQL, or any clouds like AWS, Azure, or IBM Looming, so whatever, if you want to analyze the data in the form of pictorial form, the best solution you can go into Tableau. The best solution you can move into Tableau. So data analysis is very fast with Tableau. Okay, data analysis is very fast in Tableau, and visualization are in the form of worksheets and dashboards. Okay, and it's a paid version, and sometimes you can also take it for a trial version. Once you like it, then we can move about it. Okay, and then it does not require any technical. It's very fast in moving it on. All right, why do you move into Tableau? It's ultimate for data science. It's user friendly, and you can apply to any kind of business, and it's very fast and easy. You don't need to have any coding. The community is huge. You hold the power of data. It's easy for you to understand. So this is the website. I'm showing you the online component of Tableau. Can you see the Tableau's website? Yes, no? Are you able to see? Yeah, two participants is raised in. So exactly, you can see. So this is your home. Okay. And you can also collaboratively work on Tableau. All right, your personal space and what are the collections you have. Okay, and you have got a predefined data sets where you can take it and you can use it. Okay, you can take it and you can use it. Okay, so if you want to search for different workbooks, I can just click on workbooks. I'll get what are the workbooks that is stored, and see here you have got email performance combined. I worked on these things, so it is showing me the workbooks. All right, how many tables are there? So you will be able to collaborate so many tables and do a visualization part of it. Can you see how it has been? I've done an extract, so it is showing the extract part of it. All right, so okay, I'll just show you how it works. There are predefined. I've just uploaded the breast cancer data set. I just loaded one. You go to the file, new workbook, and you can perform the unions, the joints, and have a visualization. Okay, and you can have a visualization. So what are the columns available? Here is what is just being showing here. Okay, the fields and the things. And this is an inbuilt one that it has been given here. All right. Can you see from December? Now, if I decrease it, it automatically, this is an email performance campaign. So can you see the difference on that? If I even narrow it down, how many mails are sent, but you have my data source here. Can you see? I have my data source. I've got 4 sheets. Can you see? The campaign list is one sheet. Okay, the summary is on the other sheet, the timeline sent is on the other sheet, and the mobile. Okay, if my system holds well, I'll try to open it and show. There are 4 tables associated with that, and I'm trying to combine the 4 tables and then bringing into visualization using Tableau. All right, so what are the objects? Can you see the combined list? So this is how. So these are the tables. Okay, the click emails. Okay. Okay, what are the activity dates? Okay, the fleet, the network security, the vulnerability. Okay, so I'm combining the different 4 worksheets, and each table how many columns, and all those things are integrated. Can you see in here? Okay, so 83 rows by 8 columns. Okay, 83 rows by the sent mail. It's all onto my workbook. That is an Excel format, and from which I'm trying to bring it down to this is the data and this is analytics. I can see a constant line if I want a constant line. Okay, if I want the totals, an average, and how the distribution is being done. So this is the original one. Combining the 4 or 5 different tables, because if you want to do an analysis, you cannot do it with such one table. Right? You understand, right? You understand, right? So a lot of analytics you will be able to work on with that. So it's very easy. As you start working, you'll be able to learn towards it. And this is for a supermarket. Okay, this one is for the supermarket. So see, there are 3 types of analytics I'll show in my YouTube channel, right? I'm streaming all the data. If I hover, okay, if I'm going to on top of it, if I'm going to click it on, so what is the profit ratio of the superstore? Okay, sales are on average across the 3. How can we improve it? See on Maryland. Okay, so as you want to work with collaboratively with 2 or 3 workbooks, and each workbook contains 4 or 5 tables, everything could be integrated onto use of data visualization using Tableau. Okay, using Tableau. So whatever the dates I've selected, you'll be able to see. What are the features of Tableau? If you could see here, okay, it uses data blending, so you can combine related data from multiple sources, right? And you can use it into a single graph. I showed you the example, right? The email campaigning, 4 workbooks, and each workbook has got multiple tables and how it is. So if you have a sales data onto one relational database and sales target in another Excel file, you have to compare the actual sales with the target sales. What actually happened, what was their target, they use it in marketing. These 2 data sets, one is on a database, one is onto a Excel. Okay, you can blend both. Okay, you can blend the primary and the secondary using a left join that uses the between the primary data and the secondary data. So that those kind of, for the data blending with the different data from different sources could be taken, and it could be visualized using Tableau. It could be visualized using Tableau. All right, and the second feature, if you could see, all right, for real-time analytics like Uber, and make use to understand the dynamics of data, helps to extract and faster moving of data, interactive analytics. Okay, and the next, for collaboration of data, okay, and for collaborating with different team members, sharing the data, following up the queries in companies, right? Big companies they use. So what are the companies that they use Tableau? Is Bank of America, Cisco, Google. I'll show you an example of Google, how it uses on interactive analytics, Audi, right? Pepsi, Delight. All right. So data types in Tableaus are text values, numerical values, date and time, Boolean values, and geographical values. Okay. And when you take what are the different data connections, you can do it using Microsoft SQL, a CSV file, Google's BigQuery, Windows Azure, Microsoft SQL, Oracle DB, and other ODBBC. Whatever is that's what it provides. The best feature is data blending. So you have a data server of different data files. It goes to the data connector. SQL means SQL, Tableau engine, and then components, and according to the gateways. So you want to have, and also you have got visualization, because my system is little slow today. Okay, you also have visualization. How do you want to see how it looks into your mobile, how it looks onto your system on different versions and Android? Those things could be done maybe in the future. So this is how it shows, see, on any Spotify history, how many that you viewed, how many of them are there, right? And then for net-based sales, okay, from different features, how it does, and the library reference. Okay, now quickly, this is my website. I'll show you one example how it works. Okay, my website is cirf.co.in. Okay, Okay, I told you, no, interactive queries. Um, I'll show you on Google how it is using Tableau and Spark. Okay, on so today we have seen about how Spark works, and we saw a demo using a Scalar tool, and then I showed you how it is used in Tableau. Okay, here you can see, right, the phone, whether what kind of phone, how it is shown it on the website. Okay, and so if you're using a mobile, it's a data set that is used for analysis. Okay, I just loaded one data set. Okay. So I'll go and I'll show you how real in interactive resources the queries it works. Don't see I use a lot of emails a day because every time the emails gets bundled up, and so you can all move on to, I will just show you and then you can move on to the website that I showed, cirf.co.in. I will show you how real-time queries are being processed and how for visualization they used Tableaus, right? And by the time it is getting loaded, this is my YouTube channel. Even all these 4 days, 5 days talks, I've been streaming it. You can see it onto it. Okay, so and also I've given series of talks on different technologies, and you can like, you can comment and subscribe to the channel so that whenever I come, most of the talks I put it on online. So every time my subscribers, they ask, they want to comment or they want to listen to it on onto their free time, and it's really useful, so any doubts you are having from the 5 days talk that we have seen, you can give your answers. See, I'm live streaming it on, and all the day 1, day 2, day 3, day 4, and day 5 talks are there onto my channel. Kindly comment and subscribe to it. How did you feel? How was it easier? Whether you were able to learn. I have got a lot of talks on deep learning, artificial intelligence, about IPR, digital classroom. During this pandemic, myself and my husband, we trained more than 5,000 plus faculties around the world on digital classrooms. Okay, on robotics, on data science, so many things will be there. So kindly comment and subscribe to it, so whenever I come online you get a notification. Okay, now see, I'm going to show you when I click on audience. Can you all see the Google Analytics? Just give me 1 or 2 minutes, I'll complete it. See, when I give audience and overview, I can show you throughout from December 31st to Jan 6. I've always set it as 7. I go into my CIRF. So 2-3 things I've made. So that's, so I will show you a demo of on my company's website how we have done an analytics. Okay, audience, and click on overview. And also every month we are going to have a online internship for students on every Monday and Thursday, 2 hours per month. Okay, on every month we have got batches. If students or faculty, so if you're interested, it's only online. During the evenings it will be there. Okay, 2 hours, maybe it will be between 5 to 7. All right, and so per week 2 days, so per month we have got 4. 4 weeks. So 4 into 2, 8, and 8 into 6. So more than 15 hours of course will be there. After that, we give you guidance to develop projects. So whatever the domains that you need, you can encourage your students to take this online internships, and we provide offline also. Now we have got set of students, and it's very limited. When we take offline, they stay in our company and they start developing, and they go up to journal publications and we have got some research statements, and we tell students to formulate their own research statements also. All right, so okay, it's getting loaded. It's onto the screen. Can you see now? So overview, how many people are visiting my website? So how many returning visitors? New visitors are 86, returning visitors are 11. This is between Jan 31st to Jan 6th. Okay, if I want to have a real time analytics, if I click on overview, now I want the participants to quickly visit onto the website. Right now it is showing 0. Okay, can you all go on to your, what is the fees for the online workshop per month? That's I'll show you onto the website now. So so this is for the 15 hours training that I told you. The students and the faculties also will get internships, and after which you'll be developing a project. Okay, the fee is 3,500, and the seats are very limited, and it will occur on Jan, Feb, March until April. Not every month. So encourage students, and if you are wishing as faculties or corporates, anybody, and I will be handling the course, and it will be fully hands-on session. So on Monday and Thursday, 2 hours will be there. Once I get the number of students per batch, then the batch will get started. Okay, it will be between 5 p.m. to 7 p.m. Be between. You can share it to your friends. I'll share it to Jayanti ma'am. She'll be sharing it to your group on Twitter. Now, how many of you have opened up cirf.co.in? Yeah. Now, can you see the real-time analytics? Out of 30, only 5 has responded. Okay. Okay, you can, I will share my contact details. You can get my contact details anywhere. Okay. So I showed you, right? You were able to see how many desktops, how many mobile users. It's a real time. This is an example for interactive query analysis. All right. So I hope these 5 days, I don't know from which location you see also. So we started with big data, Hadoop, we went into HDFS, we went into MapReduce, then we learned about Yarn, then we moved on to the Peak, then we moved on to Hive, then NoSQL, and in NoSQL we saw about Cassandra and MongoDB, and today we saw about Apache Spark, and we saw a demo of using Scala language. All right, Scala language. And then you can also try Python. Maybe if you're interested on learning to it, we can have a course, or you and your college and with your set of students and staff also can make a group and approach to us, okay, at your convenient time. But I'm available for the next 4 months only on a Monday and Thursdays. Other days I've got another events to work on, so I am not available. So Monday and Thursday, 2 days, 2 hours. So you spend just 4 hours a week. You see 4 4 so 16 hours you spend, and after the next month you'll be developing a project and guidance will be given. If you're really innovative, you can go in for journal publication of it also. Okay. Why I always say that's a real asset that you can get out from it after you do a work on your own. Can you see now 4 of them, and out of it 71, 7 of them are open, and one is onto the home page and one is on the intern page. Only 7 people are there, and I can see like one is from, yeah, one 3 from Chennai, one from Coimbatore. I don't know, from one is 2 of them, one is from Secunderabad, and 2 is from Hyderabad. Okay, I don't, but see, and only they are in the home page. As you can, one or two of you traverse to any other page, or the number of, yeah, I see one of them moving into in-plan training page. See, this is what is real-time analytics and dashboard. See how quickly I'm able to analyze, right? Can others move to, there are 30 people, leaving out, it is 29. Can you move? Yes, please. Yeah. So as every second, as you see how huge volume of data and how it is getting processed. Okay, thank you all for joining. I just want to show you a demo of it. And this is my contact details. You can take a screenshot or you can find it out. And subscribe to my channel, so whenever I come online, you'll be able to get details about it. Share to your friends, those who are in need of. Okay, thank you all. God bless. Over to the organizers.
Thank you, ma'am. Jayanti, ma'am?
Yeah, ma'am. Thank you, ma'am.
Welcome.
Is it audible, ma'am?
Yes, ma'am.
Yes, ma'am.
And I wish if participants, if you have gained new knowledge, can you take a video of less than 20 seconds or less than 1 minute, and you can send it to my WhatsApp number. How was these 5 days FTP for you personally? Okay, you can take using your mobile, take a video, but keep your mobile in the horizontal format, not onto the vertical format, and send to me through the WhatsApp. Can you, how many of you will give a video feedback? Okay, yes, two of them have raised hands. I expect everybody to give. What was it? Could be good. You learn something new, but keep your mobile horizontal, but less than 1 minute. Be quick, be specific on how was these 5 days FTP. Kindly share it with me. That would be my best takeaway. If I get a sequence of it, I will. You can all. I will also publish it onto my, after editing. I'll publishing onto my YouTube channel, and you can see yourself. Okay, maybe you can take till tomorrow evening 5:30 to Saturday, Sunday, after the weekend, during the weekend. Kindly share it with me. So that would be the best take me. What was your learning out of these 5 days FTP? Because the first FTP of the first talk series of talk of the year, and I have also learned a lot. Thank you.
Thank you, ma'am. Good evening to all. As all good things come to an end in life, today we are in the end of the faculty development program. On the Sathyabama Science and Technology, I, Jayanti, take this opportunity to propose vote of thanks to those who have directly and indirectly contributed to this faculty development program on big data adoption and analytics of cloud platforms organized by our institute. At the outset, I thank our chief guest and resource person, Dr.Doreen Robin, ma'am. We are really enlightened with your knowledge and questions. We are thankful to our Honorable Chancellor, President, Vice Presidents for their motivation. I would like to thank our Vice Chancellor and Dean Madam for their enthusiastic support. I extend my gratitude to Dr. Lakshman sir and Dr. Rikneshwari ma'am, head of the Computer Science and Engineering Department, to organize a FTP program even in the midst of pandemic. A special thanks to the organizing committee, Ms. Sri Vidya, Dr. Anu Bharati ma'am, Mr. Amandeep Singh sir for their unflinching support and coordination. Our heartfelt thanks to our faculties, research scholars, and students for active participation. With the warm words and a kind message, we move to the end of 5 days faculty program development program. Thank you everyone once again for making it a grand success. Thank you all. Thank you, ma'am.
Welcome, ma'am. Welcome, ma'am.
I request all the participants to switch on your videos.
Jayanti ma'am, you could be a little more back so that your entire face will be seen.
Yes, ma'am.
Yeah, Anu ma'am is perfect.
Yes, ma'am. Just a minute, ma'am.
There's so many of you. Yeah, nice to see Gauri ma'am, Daphne, Surya ma'am.
Daphne ma'am. Gauri ma'am.
Yes. Vinodini ma'am, Krishna Kumar, Sai. Sri Vidya ma'am, Jeevan. What about others? There are many of you. Memories are the best aids.
Okay, ma'am. Thank you.
Thank you. All the
Thank
best.
you all. Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, guys. Thank you
So
to all.
participants, you will receive the certificates to your registered email ID. Okay. Thank you so much. Thank you. Thank you all.
Thank you.